Yeah, I'll just record the meeting. So maybe people who aren't here, they can watch this later. So yeah, let's get started. I'm gonna share my screen. So yeah, we'll talk about some triangle problems today. Lou, are you here? Can you hear me?
Yeah.
All right, cool. So today we're gonna go over some AMC problems that use the Pythagorean theorem. So this is a pretty important thing that you're gonna need in a lot of math. So sorry about the noise in the background. But so the Pythagorean theorem can be used for like problems such as this one. So let's go over this real quick. So this one says, Bill walks 1/2 mile south, 3/4 mile east, and then finally another 1/2 mile south. How many miles is he in a direct line from his starting position? So we can solve this problem pretty easily using the Pythagorean theorem. So let's first draw a diagram to see where he's walked. So he's walked 1 mile south. He's walked 1/2 mile south. He walks 3/4 of a mile east. So he walks this way, 3/4 of a mile, and he walks another 1/2 mile south. So we need to find the distance from a starting point, which was here, to his ending point, which is here. We can do this really easily using Pythagorean theorem to find a straight line. So first, Pythagorean theorem works like this. It's a squared plus b squared equals c squared. So that's the whole thing. So it's basically saying if you have a right triangle, then this side squared plus this side squared will equal this side squared. Oh, someone else joined. We'll wait for them to connect to our audio real quick. Hello. Yeah, Joyce, we're just going over, today we're going to be going over some triangle problems. So we'll spend half the meeting working on this. We'll spend around 30 minutes on this, and then we'll do a little puzzle at the end. So yeah, we're talking about the Pythagorean theorem. So yeah, do you know the Pythagorean theorem, Joyce?
Yeah.
Yes, you know how this works, right? So I'm just going to go over the really basics of this in case Lloyd doesn't know this, but we're going to go over this, and then we're going to solve a few questions. So anyways, we can use the diagram that we drew for this problem and make it into a right triangle, right? So really, this is just a triangle with length 1 on the bottom and then 3/4 on top. And then we can solve for this one. So let's solve this. We plug these things into the theorem. So we know, we'll call this side that we're looking for x. So we know x squared equals 3/4 squared plus 1 squared. And then 1 squared is just 1. And 3/4 squared is 9/16 plus 1. So really this equals, so this problem will equal 25/16. Yeah, we can't really simplify that. We can, it's just 1 and 9/16. Wait. Did I get my directions wrong? Wait 1 second. No? Anyways, but if we solve it using the Pythagorean theorem, we get that this side here, oh, we need to get the square root of this. So we know that x squared equals 25/16. And after that, if we get the square root of that, which is just basically what number squared will get us this, we can get 5/4. So our answer here is 1/1/4. Does that really make sense to everyone? Sorry, I kind of explained that a little bit weird. But okay, now we're going to go over some more complicated problems. Okay, so let's read this problem real quick. Non-convex quadrilateral ABCD shown below. Angle BCD is a right angle. So BCD right here, this is a right angle. AB equals 12, I'll label these sides. BC equals 4, CD equals 3, and then AD equals 13. So we need to find the area of quadrilateral ABCD. Okay. So we can also solve this problem using the Pythagorean theorem to find the missing side lengths we need. So first of all, we can connect, let's try to find side length BD here. All right, so we can use the Pythagorean theorem to find this. How can we solve for BD? Does anyone want to give this a shot? Do you guys understand this kind of stuff? It's like the difficulty level of this, right? Okay, never mind. So we're gonna solve for side BD first, okay? Because we know that this angle here, BCD, is a right angle, so we can solve for that. So let's solve for that. So 3 squared plus 4 squared equals, we'll call it side x here, x squared, right? And if you do this, we'll get that x squared equals 25. So x equals 5. So 3, 4, 5 is one of these Pythagorean triples. There are a few triangles where all the numbers will match up in whole numbers, and this happens to be one of them. So now we know that x equals 5. So do you guys remember last week how we went over how to find the area of any triangle? Right? If we want to find the area of any triangle, we just need to get the height times the base length. So we just want to check if this right here is a right triangle, right? If the 5, 13, 12 is a right triangle. And we can also use the Pythagorean theorem to do this. So if we want to check if this all works out, we can do 5 squared plus 12 squared equals 13 squared. Right? If this works out, then we know that we'll have right answers. So 5 squared is 25 plus 144. And then 13 squared is 169. So does this work out? Yes, it does. So now, because this works out, we know that this is a right triangle. And then from there, we can just find the area real quick. Does that make sense? Oh, you guys can use the chat if you don't want to like unmute or. All right, cool. So now we know that this is a right triangle, so we can just solve for the area. So 5 times 12 is 60 divided by 2, because we don't want the whole rectangle area. And that gives us an answer of 30. So this is another pretty basic question using the Pythagorean theorem. So now we learned that we can also use this to check for right triangles, because this question didn't necessarily give us a good way to find the angle here. Okay, so now let's go over this one. This is a little bit of a harder question. I think this is probably after question 15. All right, so let A be the area of triangle with sides of length 25, 25, and 30. And let B be the area of the triangle with sides of length 25, 25, and 40. So what's the relationship between A and B? So A is the area and B is also the area. So first, let's draw out these triangles. So it's 25, 25, 30. I'll draw a slightly wider triangle. This one. So we need to find the relationship between the area of this and the area of this triangle. So do you guys have any ideas how we can do that? Okay, so we can again use the Pythagorean theorem here. So we don't know if these triangles are right angles, right? We want to make them into right triangles so that we can figure this out. And so how we can do that is we can just cut these down the middle here, and we can just find the height. So how can we find the height using the Pythagorean theorem here? Anyone have any ideas for this? If you guys have any ideas, you can just type in the chat or you can unmute for how we can do these questions. Okay, so we can just, if we draw the line straight down here, we can make this a right angle. We can just call this the height because this is an isosceles triangle. We can draw this and we'll cut this down the middle. So now we have two right triangles, right? And now you can find this. So we know this side length here is equal to this side. And so this gives us a triangle, something like this. So how do we find x using the Pythagorean theorem? You guys have an idea for the equation? We can use this. We just need to solve for x. If there's anything I'm talking about that you guys like don't understand, just let me know. I can go into more depth to explain that. And not really? Okay. So again, we know that the Pythagorean theorem here, we can use this to find x. So Pythagorean theorem says that this side right here, we'll label the sides again. We know a squared plus b squared equals c squared, right? So in this case, we know x squared plus 40 squared, that's b, will equal c, which is 25. All right, so x squared is just, oh, Hambo's here. Hello?
Hey, can you hear me?
Yeah.
It's actually you forgot to split the 40 in half. It's 20.
Oh my god. Yeah, I forgot. My bad.
But as he was saying, it's like this is a really simple application of the Pythagorean theorem, and you really just put the numbers into the formulas and you solve for x. So it's x squared plus 20 squared equals 25 squared, and that means x squared equals 25 squared equals 20 squared. And I'll do the calculations for you. It ends up being x squared equals 225. So x is equal to 15.
Another way we can find these big squares, so this actually matches a squared minus b squared. So this is a pretty common thing you can use. If you ever get a squared minus b squared, you can just do, this answer is equal to a plus b times a minus b. So that's pretty useful if you ever want to do these big numbers in your head. But
Yeah,
now
it
we
is
get,
known as the difference of squares formula.
yeah, so this is the difference of squares right here. So anyways, now we know that x is 15, we can go ahead and solve for this area, right? So now we know x is 15. So you know this triangle's area is just 20 times 15. So that's 300. I'll write that in the middle. And we can do the same thing for the other one. So how can we do we can really use the same kind of equation to solve for the missing height on the third triangle, on the other triangle.
Hey, let's let Loy or Joyce, do you guys want to set up the equation this time? For the second triangle, 25, 25, 30. Loy, Joyce. Yeah, Joyce, go ahead. Joyce, if you would like to type in the chat, that's fine as well, or you could unmute. Oh, I see your annotations. Would you like to just write the equation? That'll be fine as well.
Where do I? Eh,
Hey Joyce, Jonathan actually already drew a diagram. If you could just tell us what the equation would be.
Pretty much literally the same thing as the other side.
Call this X.
Yeah, so we're just going to solve for x, right? So right, so this is the Pythagorean theorem, but for this we're solving for x. We can write this as x squared equals. Right, so using the difference of squares that we went over, how can we find the answer for this?
Lloyd, do you want to try it? Just put the numbers in the formulas and you'll get a very fast way of solving this. Philip, would you like to try?
I am sorry. I'm afraid my lower intelligence will not allow me to attempt to solve this problem.
Well, Philip, you see, you just have to plug the numbers into the equations because in this case, 25 is A and 15 is B. So what would you get for the first parentheses?
X plus 20.
Well, it would be
Oh, we're solving
25.
We're solving
plus
for
15.
25 squared minus 15 squared.
25 squared minus 15 squared.
Yeah, we're going to use the what was it? Difference of squares formula.
Oh, so then it'd be like 25 plus 15.
And the second one?
25 minus 15.
Very good, Philip. You got it. So that would be 40 times 10, and that's 400.
Wow, I didn't know I could do this. Thank you so much for teaching me the ways.
Good job, Philip. And here's an observation that you could actually make. If you notice from the first triangle, the problem was 25 squared minus 20 squared, and you got 15 squared. So that means 15 squared plus 20 squared equals 25 squared. So in the other case, it's really just turning the answers in the subtraction around. It's now 25 squared minus 15 squared instead of minus 20 squared. So you could really just use the first triangle to help you solve the second triangle. But either way, we now have all of their sides, so let's just find their areas.
So yeah, we know that the height of this triangle here is 20. So you solve for the area. So that's 15 times 20. That was also 300. So our answer here is A equals B. Because these areas are identical. Does that make sense, everyone? Oh. All right, we'll move on to the next one. Yeah, so this one is another application of the what was it, the Pythagorean theorem, but this time we have a cube instead of just 2D. So this may look complicated at first, but it's actually not that much different from just doing it in 2 dimensions. So we'll go over how to do this. So let's read over the question first. In the cube A, B, C, D, E, F, G, H with opposite vertices C and E. So here's C and there's E. C and E, J and I are the midpoints of edges FB and HT. So we can go ahead and label these edges real quick so we know which sides are the same. Respectively, okay. And then let R be the ratio of the area of the cross-section, EJCI, so that's the area of this little shaded part, to the area of one of the faces of the cube. So what is R squared? You want to find the ratio squared. So how
Well,
can we go
actually,
about solving this?
Before we start this,
Right.
does anyone want to take a guess at what is the shape of the cross section, the gray area?
If we flatten this out to draw it in 2D, what would this cross-section look like? This part right here.
Lloyd, Joyce, do you guys think it's a rectangle or a square or a rhombus? What do you think it could be? Well, if you look at the side lengths of the edges, you'll see that every one of these sides in the gray area has the same edges. So by the Pythagorean theorem, they would have the same length because the sum of the two numbers that are identical for each edge would give the same side length for each edge of the cross section. Does that make any sense to you guys?
Here were the side lengths I drew. So we know that all the edges, we know that there are midpoints here, and this is a cube. So you know that all of the normal edges of these are the same. So I'll switch here. So you know that these edges are all the same, right? Because this is a cube. You know these are all equivalent because this is the midpoint. So therefore, by the Pythagorean theorem, all of these edge lengths would also be the same.
Yeah, and therefore we know that the cross section is a square. So we're really just comparing the areas of two squares. And another important thing we have to know before solving this is how to find the area of a square. Do you guys know the formula for this, or should we go over it real quick? Lloyd, Joyce, do you guys know the formula for how to find the area of a square? All right, Joyce. So basically, in a square, it's actually pretty much the exact same thing as a rectangle, except all of the side lengths are now the same. And as we learned in the previous class, the way to find the area of a rectangle is to multiply its length by its width. So in this case, you can pretend that the length or the widths are the same. So it's really just one side times another side, which gives you the side length squared. So in any square, you would take its side length and square it, and that would give you the area. Does that make sense?
Does everyone get this here?
All right, good. And so now we just have to basically find the side length of the cross-section square, because once we have that, we can just find the area and compare it with the other square, which we already know the side length. So since they didn't give us like the exact number for the side length of the cube, let's just call it x. Right. And so since we know that I is a midpoint, and remember from last class, we know that a midpoint divides a line to two equal halves. So that means the green edges are 1/2 x, right? Everyone agree? And then it's just a basic, simple application of the Pythagorean theorem to one of these small little triangles on each of the faces, and then we will get the edge.
Can you guys try to fill in this here? We're going to solve for this one.
Remember, it's just side lengths squared, and then you sum them up.
And if
Lloyd,
working with
would you
x,
like to try this?
also if working with x is hard for you guys, remember in this problem, all you're looking for is the ratio, so you can actually set the side length to whatever you want. You can set it as a number if that's easier for you. Like you can like set this side length to like 2, for example, if you wanted to do that.
Well, again, you just square them and sum them up. So it's going to be x squared plus 1/2 x squared, which ends up being 1/4 times x squared. And if you add the fractions, which is the coefficient of 1 to x squared, you get 5/4 x squared. Or you could write it as 1 and 1/4 as Jonathan did. But usually we would prefer the improper fraction form, like 5/4. And then at this step, you would basically take the square root of both sides because you want to find the actual side length, not square of the side length. So that means you would just get z equals the square root of 5 over 2.
Everyone write it as that? Yeah.
Right. And then, as we just said, the area of a square is the side length squared. So we would just square this again to get 5/4 x squared. And knowing this, you probably didn't have to even take the square root of the equation because you knew you have to square it again. But then we already have the area, which is 5/4 x squared.
So this is the area of the shaded face. Now we need to find the area of the normal cross section. So what is that? Since we said one of the side lengths as x, what would the bottom be?
Joyce, would you like to answer this? It's the formula that we just went over. The side length of the cube is x, so that means the side length of the square we're trying to find is also x. So in that case, what would the area be? Remember, it's the square of the side.
Yeah, so we're just looking for the area of one of these normal faces. It's like a normal side of the cube here. We're looking for this section.
Again, recall how it's really just a rectangle, but the sides are the same. So you just take its length times its width. But they're the same, so it's really just side length times side length.
Yeah,
in this case, that's
did-
x times x.
so this would be x squared. So remember, we're doing 5/4 x squared over x squared because that's what the question is asking. We're looking for the area of the cross section. So we're looking for the area of this bit here in the middle of the cube versus one of the area of the faces of the cube. So the area in the middle is this, and the area of one of the sides, which is this bit here, that is equal to this. So that's
And so when we take the ratio, it would end up being 5/4, and the answer would be A.
So here we can just simplify, cross out the x squared, so that gives us 5/4.
This problem is a little tricky, so does any of you have any questions about it? Any part that you don't understand?
Yeah, this is a problem 24 on AMC 8, so this is not a really easy question.
Pretty hard. Any questions? Joyce, does that make sense to you? Or do you need any clarification? The middle part.
What do you mean by
Which middle part?
The
You mean
shaded-
how we found it? Yeah, go ahead.
like the area here?
Yeah, I don't understand that.
Okay, yeah. So remember, we set the side length here as x. You know what? I'll explain it again, but I'll set it as a number since that might be a little bit easier to understand. Say we set the side length, I'll draw a different cube over here. we'll start in the bottom here to re-explain this. Well, we change colors to make this a little bit easier. So we're looking for this
Basically,
middle
we
square.
want to find the area of this red square right here. And in order to do that, we have to know its side length, right? Because then we can just apply the area formula for a square, which is the side length squared. So in order to find the side length, we have to use the Pythagorean theorem because if you look at this little triangle right here, let me point it out real quick. This little purple triangle right here, we're trying to find the longest side of this triangle, which is also known as a hypotenuse in a right triangle. Oh no, the zooming made my thing go away. Yeah, but yeah, Jonathan's circling the triangle right now. We're trying to find that, and we know that its side length is 1 and 2. So in order to find the desired side, we just have to use the Pythagorean theorem.
So we're looking for the side here in yellow, because once we know this side here, we can go and solve for this here.
Does everything we just explained make sense to you? Just so that we know. Yeah. Okay.
Yeah, because remember, this middle section may look kind of weird, but at the end of the day, it's just a 2D shape. All we need to know to find the area is just the side lengths, and then we find that through these edges here. So I'll write down the equation for this. So this question mark here, this will equal to 1 squared plus 2 squared.
Question mark squared.
Question mark squared, yeah. So that'll equal 5. So from this, we can find that this little section here is equal to the square root of 5. So question mark squared is equal to that. So question mark will be equal to square root of 5. And remember, this inside shape here is just another square. It's just angled slightly differently. So to find the area of that, we can just get the side length squared. So this side length here times this side length here will give us the area. So this is just equal to, let me find some more space. It's just equal to square root of 5 times square root of 5. And that is equal to, sorry. And then now
Wait,
that we
it's
know,
5. It's 5.
oh, wait. 5. And then now that we know the area of the side here, it's just 2 times 2. So to find the area of a normal side, just a normal square on the side here, it's 2 times 2. So that's equal to 4. So actually, the answer isn't 5/4. Wait, we did that wrong.
No, it's right. Yeah, it's 5/4.
The ratio to here is 5/4, but the question asks for what is the ratio squared. So we're gonna.
Oh, right. Yes, in that case, it would be 25/16.
So using these numbers that we solved here, we got that the area of the red bit here, the red square, that is equal to 5. And the area of the normal little blue square here, I'll draw it out here. One of these, this little black square here, that's equal to 4, because 2 times 2 equals 4. So now we just have to square this. And to square this, we just multiply it by itself. So 5 times 5 is 25. 4 times 4 is 16. That's how you get our answer.
And hopefully that was a bit easier to understand because I know like the X and all that variables can be intimidating, but it's honestly the same basic idea. It's just that we weren't given an actual number for the side length. So we just give it a random variable name, like X is just whatever name we give it. We could also just set it to a real number like 2, but it really just depends on how you would like to do it. But does the second explanation make sense, Joyce?
Yes.
All right, good.
So like for this kind of problem, you can set it as a normal number, but as like if you do AMC 10 or AMC 12, the problems get a lot more complicated. So setting something to X makes solving everything a lot easier. But for AMC 8, most of the time you can just set it to a normal number and solve. All right,
Let's go on to the next one.
All right, let's go through this problem real quick. So rectangle ABCD is inscribed in a semicircle with diameter FE. So that means all the points are touching the circle, it's inside of it. So the diameter of this semicircle here is FE, shown in the figure. So let DA equal 16. FD will equals AE, which equals 9. That's all labeled here. And we're looking for the area of what looks to be a square. We don't know if it's a square though. So we're looking for the area of ABC.
No, it's actually a rectangle. It says it's a rectangle.
Yeah, but we'll solve for that real quick. So how can we tackle this problem using the Pythagorean theorem? Remember, what do we need to find the area of ABCD? We're missing a side length here. So how can we find this side length? I'll switch colors.
This is a very tricky problem. It's really just the first step that's a bit hard to see, but once you get it, it's really easy. So let's be a little creative here and brainstorm a couple of ways we could solve this. So we know that we need the red side to solve the problem, because if we have the red side, we can just multiply by 16 and boom, we have the area. So what are some ways you think you can solve this? Joyce, Lloyd, do you guys see any ways we could start on this problem?
Remember, we want to look for right triangles. Way to draw a right triangle in here, because if we can find a right triangle where we know 2 of the side lengths, we can use the Pythagorean theorem to solve for this. So can you guys think of a way to do that?
Philip, can you think of any ways to start on this?
Could you zoom out a bit?
Yeah, sorry.
Remember, we just need a hypotenuse that we know the length of, and then we could just use the formula.
Yeah. Well, I guess first of all, we know CB is 16.
Good.
And yeah, I guess, yeah, that would be, the entire thing would be 18 plus 16, which is like 34, I think.
Good. Yeah.
And then individually it would be 16 plus 9, which is 25. Wait. Yeah, 25.
Well, Philip, actually 16 is the side length.
Oh yes, it'd be 8 plus 9 then, which would be 17.
Well,
And
that's
so-
something we figured out we figured out the radius, which is good, but we haven't quite gotten the red side yet.
So how can we use the radius here? Now that we know the radius here, how can we find the red side? So remember-
Can I try? All right, so I think if you go from midpoint of DA to B, that would still be the radius. Draw like line, and that'd be 17. And
Good.
then from midpoint to A, that'd be 8.
Mhm.
And then we can use Pythag to get the last side, the red side.
Good.
And this would work for
Excellent.
both sides.
Yeah, so this is something really important. You know, when you have geometry problems in AMC, where you need to find side lengths, you can realize that, you know, if you have a radius of a circle, it stays the same for any point on here. So if we draw a line straight up to here, that'd also be 17. So that's a pretty good way to be able to draw triangles and solve for missing side lengths. So how can you use the Pythagorean theorem to solve for this? Joyce, Lloyd, do you guys have an idea? It's another application of this.
It's the last problem to test your mastery of this excellent formula.
Yeah, this is the last one before we move on. You guys can try to do this, but I think this one's a little bit
Pretty
hard.
hard.
And it requires some concepts that we'll probably explain in the future.
Yeah, we're gonna probably do a next class, but not this class. So this is the last chance. Well, Philip,
Yeah,
go ahead.
I'll go. All right, so if you use Pythag, a squared plus b squared equals c squared. So 8 x squared equals 17 plus 17 squared plus 18 squared.
Well, Philip, this is actually a pretty common mistake that students make where they see two numbers and they add them together.
Oh,
However, you have to remember that you're adding a squared and b squared together, and a and b are always the legs of the triangle, which are,
such an elementary mistake. I'm sorry. All right, so actually it's 8 squared plus x squared equals 17 squared.
yep, you got it.
And then we can just rewrite this.
And I'll just do the calculations for you. This would be 289 minus 64, which ends up being 225, which, if y'all could remember, is the square of 15.
Wow.
Yeah, it's pretty useful to memorize everything up to like 16 squared.
I see it now.
Yeah, so
Good.
now that we know this is 15, it's pretty easy to get the answer, right? So what's the
Uh-huh.
answer for this?
The area would be, so since that is 15, we merely multiply 16 by 15 to get the number, oops. 240.
Yep.
A
Hip hip hooray.
All right, Joyce, Lloyd, do you guys understand that? Do you want me to go over anything again? We have enough time to do that.
It's fine. I got
Okay.
it.
Cool.
All right,
So
good.
yeah,
Then let's. Oh wait, Lloyd doesn't. Lloyd, what part do you not understand?
let me just go over the whole problem again, or is there a specific part?
Oh, okay, you do understand. Wait, then
Okay.
Oh wait, no, as in no questions. Okay, okay. All right, ladies and gents, now we will be going to the puzzle.
I actually didn't have this open. 1 second.
Right, so today we are doing a puzzle called Colored Loops. And it's fairly straightforward. So basically you want to start on one colored arrow and go all the way around until you reach the same arrow again. And you have to follow the number written on that arrow. Like, for example, the 2 means you travel 2 arrows. And you jump to the second arrow. And you basically fill in the gray arrow so that the loop is complete. And you can start on any colored arrow and go back to itself. Does that make sense?
No.
Okay, I'll try to explain
Alright,
it again. So this is just a logic puzzle here. So the goal here is to make sure that you're trying to fill out the empty spots to make sure it all follows the rule. So basically, it all goes counterclockwise. It's a loop. And then so the number on the arrow tells you how many steps it will jump. And the color on the arrow means that every single spot this goes to has to be the same. So for example, if this blue here, if you go 2 spots from the blue, go 1, 2, this spot also has to be blue. But then now we have to figure out the number of steps that'll take to get this arrow back to the blue, right? Because we can't have it land on green since it's a blue arrow. So it's gonna have to travel 1, 2, 3 steps. And then since this one's gray, we need to figure out the color for it. So now we can see how to get to that. So green here would go 1, 2 steps. So this will tell us that this is green. And also if we travel 2 steps down, following this, we go 1, 2, and we land on another green spot. So we just have to fill in the blanks to make sure it all follows the rules. And then that's how you can solve the puzzle.
Does that make sense?
We'll go over a few more to make sure you guys all get it. The first few are all pretty easy. So remember, we have to make sure that all the colors, all the arrows that each color will land on has to be the same. So the green one can only land on green arrows, and the blue one can only land on blue arrows. So now they already have the numbers filled in, so you just have to fill in the colors. Do you guys have a guess for this?
Could start on the green arrow.
So is 1 green?
Good.
Yes. Move 2 steps, 1 would be green.
And then then 3 is blue.
Mhm.
and 2 is green.
Yeah, so this makes all work. So the first few puzzles are pretty much all the same. We'll go do one more of these and we'll move on to a harder one.
Lloyd, do you want to try this one? Philip, would you like to try it?
Could you explain how it works again? It's kind of hard to understand.
Yeah, so basically you the number on the arrow tells you how many arrows to go. So for example, the 1 tells you to go to the next arrow and 2 tells you to go to the next 2 arrow.
Uh-huh.
And the color, like you have to stick to the same color for like for example, if we start on a blue arrow, you cannot go to a green arrow, like if that makes sense. Say that the
Oh, I
3
see.
is green and say that the other one is blue. So if you go to the green, like then your puzzle is flawed and it doesn't work.
All right.
So let's try to fill out all the blue ones first, since that's the hint they gave us in the beginning.
Okay. So we got the 1 blue, and then the 3 blue, obviously. And then the 3 blue. And then the 1 blue,
Wait, this one?
and then the 2 blue. Does it work?
Yeah.
I'm a genius. I can't believe it.
Yeah, so it's all just about following the rules. At least that's what it is like for the first few ones. So we're gonna go to one where they give us a few more arrows.
Oh my God.
All right. Anyone's up for the challenge? Joyce? you
Oh,
wanna go?
yeah. I guess let Joyce do it.
Yeah, we can
What?
come with a few strategies for this. No, we all work together to solve this one. This is
All right. I'll go. Yeah,
Yes, we're all a big math family here. A
Well,
math
well, let's just
circle,
start
if
with
you
the-
will. A math
let's start with the
circle,
blue.
if you will.
All right,
Which-
let's start with the blue one.
Hold
All
on.
right.
Uh,
You might want to start by filling out the blue arrow because it's actually pretty much already, the loop is pretty much already done. So
we just have to fill in 3 colors for this. So let's figure out how many steps we need to do for all these.
remember, you want to be
Yeah.
able to reach
Yeah.
from here to here. So you really just want to figure out how many steps you need to go from the blank blue arrow to the blue arrow with the number 5. Well, if you just count the number of arrows in between, you would say that you need 4 steps. So the first arrow will be 4.
All right, what about the yellow arrow? This is pretty much the same way to do it.
two,
And then what about the red?
4,
Yeah, so this one was a lot of stuff, but really it's not that complicated since they had most of the stuff done for us. So
Yeah, let's skip to like 15 or something. Oh yeah, this one. Let's do this one.
Okay.
All right.
So remember, the strategy here is to start with what information they give you. Because at the end of the day, all you have to do is make sure that this puzzle, everything on here follows the rules and we can solve it. So let's go off the first lead that they give us, which is the yellow arrow. So how we do this. Mhm.
and then 1, 2, 3, 1, 2, 3, 4. And then yeah. 1, 2, and then 1, 2, 3, 4. Oh, that okay.
Yeah, so that comes full circle. So now we can take a guess for the other one. So we can just pick any one and just follow it and see what happens, right?
Yep, you can just pick any other color. I guess technically if you just fill everything with yellow, it still follows the rules, but that's pretty easy. So let's try something like different colors, and now let's just say purple.
All right, let's just pick a random one. So this one right here. And we'll follow it through again. So the same pattern pretty much.
Okay. So again, 3 is purple. And then 3 is purple. Then 3 is purple.
And
Yeah,
now
then
we're
it was-
out of colors, and we need a new color.
Yeah.
Blue.
Can you recognize the pattern here?
Yes.
Yeah, so it's just another pattern of 2s and 4s, right? This is the same as yellow.
Yeah.
So that's it as well. Boom. All right, let's see if we can find a puzzle that's impossible, because there are a few on here that are not possible to be solved. See if we can find one with some missing stuff.
That's fine.
Let's just do that one. Puzzle 28.
28.
Yep. And then we'll go to the square ones.
I just fill everything in with your.
All right.
This one seems extremely hard, almost impossible, if you will.
Wait, so 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Could it perhaps be that all of them are red? No, it couldn't.
1, 2.
You do realize a pattern from this. This is actually a pattern to recognize for doing these puzzles. If you solve an arrow and it goes a little bit beyond each one and it moves forward incrementally each time, then you'll end up solving the whole thing as yellow.
Press
Okay.
them.
Okay,
Yeah.
the circle ones only get so challenging. They're all pretty easy. Let's do the square ones.
Yeah, so this one actually gets worse, this puzzle. or-
What? But it's called We're the Math Circle. No way.
No, we're now the math square now.
What is this?
This is the same thing as the circle, but this time it's a square grid.
What is
So
this
all the same
unholy
rules.
abomination?
You
Oh,
need to
wait.
figure out the steps and the colors.
So
All right.
So the boxes here that don't have an arrow on them, you need to figure out the direction.
So
Okay.
basically, in addition to a number and a color, you actually have to figure out the direction now as well.
All right. For the bottom right one, it's an up. I'm pretty sure.
All right, and what color?
It would be the color blue. All 4 corners would be color blue.
It's another circle.
Let's see. I am perhaps 100% sure that the arrow on the left, the red arrow on the left is number 2. And then the red square, it's arrow that points right. That's a 1.
That points right.
Or left.
You can't go into the wall, right?
What do you mean? All right. And then the last one is an arrow pointing up. That is 2 and is yellow. So they're all self-sustaining paradoxes.
There you go.
Good.
So you can see that the cubes are a little bit more interesting. So let's try to find some hard ones that we can tackle together. So let's go do a really hard one.
no.
All right, let's see if we can all solve this
Hey.
one together. How many minutes do you have left? You have
We got
15
like
minutes.
5 minutes, so we'll see what we can do.
Why can I not full screen?
Instructor Jonathan, perhaps you'd like to share the pain with us.
Yeah, I'll
plebs.
visit with you guys. I'll just zoom in, I guess. I can't full screen for some reason. It's really
You won't be able to zoom in. It will just get bigger.
It's fine. We'll just do it like this. It's fine.
I got scammed. Oh wait. There you go. Wait, is this work?
Scroll down.
There you go.
Yeah, good.
All right.
How are we gonna start this?
What?
Really-
Maybe just
Well, I mean, we know that the arrow on the top right corner is blue.
Oh yeah. There you go.
Excellent observation.
Excellent observation. Now what?
I am so smart. We also know that the arrow on the top left is yellow. All three arrows are yellow. All three arrows on the
And
left
could
are
you
yellow.
explain your reasoning behind that?
The two bounces to the one, which bounces to one, which points to yellow, and so they must all be yellow.
Good.
That's good enough logic for me. I'll take it.
After that, I am 100% sure that the 4 is also yellow. On the left.
This one?
Yeah.
Joyce, Lloyd, do you guys have any ideas for the other ones? Kind of lost. I have no idea. This goes here. There's a few options.
Yes, there is a few options indeed.
Should we just mess around and see what happens?
It could
Yeah.
either go down or up. But
Let's
by
go
the way,
down,
the
'cause we
left
need
one, the
to-
left one is blue. The left one is blue. The last one, it's blue.
Well, think about this. We want to be able to fill out. We have to cover every single one. So I think we should go down because otherwise we won't be able to hit this one anywhere else.
Oh, I got it now. I got it now. What's it? I'm pretty sure the blue one on the bottom is 3 or 4, maybe. Yeah, it's a 3. It's a 3. No, definitely. It can't be a 4. It's a 3 that goes right.
Goes right. Oh, you think this is okay?
Yeah.
I see.
And then the 3 bottom is a blue.
All right, so guys, other people, let's try to finish this real quick. Now that we know,
Louis is AFK. All right,
Yeah,
and
but
3
we just want to like form a loop here because we want to be able to start any
Yep.
arrow and go back to the starting one. So
yes.
Oh.
I'm confused.
oh. Okay, so this goes to 3, which goes here, which goes
Yep, and then that which goes there, and then that arrow would obviously, or I mean, maybe not obviously, but like, how do I? Let's see. It would point there, and since it's a 1, it either points up, down, left, or right. So it would have to point up, or else the paradox fails.
I'm not sure about this, Philip.
I'm also not sure.
Maybe
It
I'm
doesn't seem
wrong.
to quite work.
I can't believe it. Me wrong? Impossible. Nay, I say nay.
Joyce, do you have
problem is
any ideas
impossible.
on like what we could do? Because Philip's loop doesn't seem to be working.
I don't understand.
I also
Wait.
don't understand. I'm just gonna try. We should just try something. Let's see what happens.
Wait, Joyce, do you like not understand like the rules of the puzzle, or like do you not understand like what we're trying to do in this particular?
Oh, I figured it out.
I don't know what we're trying to do here.
Oh, Jonathan. So,
Wait, I'm sorry. I got distracted. I figured it out.
all right. So like basically, we want to be able to fill out this entire thing so that every single spot has a number, a color, and a direction. So you see all these like gray ones and gray squares. We want to give all of these a color, a direction, and a number. While also satisfying the rules that if you start at any arrow, you could go with the number and color instructed and go back to the same arrow. Does that make sense? It's like the same, it's like the loop puzzle, except you have a new direction.
Okay.
All right. All right,
I'm
Jonathan, you
lost.
said,
Where are we right?
what was that?
We don't have a spot that we're in right now. We're just trying to work it out. You can start from anywhere on here because we're kind of lost.
Oh. Um.
I think this is impossible because that red one, it can't possibly fill any of those spots, I feel like.
Well, that's good reasoning.
Yeah, could you click on
But
it?
do you know that you
Wait,
have
no,
a
no,
two
no,
of
no,
them?
no, no. We filled this arrow. We filled this one in. Remember?
Oh, that's true.
This could be.
Oh, so that could be red. That could, wait, no, that does, yeah, that could be red. That could be red. The
Do you
two,
think we can make a loop like this?
yeah, exactly.
I see what you mean.
Or no, that wouldn't be the loop. Yeah. Wait, what? Yeah, that would be the loop. Red. Yup.
Oh, this blue doesn't work. Wait, is this impossible? Do you guys think this is impossible? Should we check?
Yes, I feel like it is impossible.
I don't think it's impossible. I just think we're not. We haven't found the solution.
We're out
yet.
of our depth. We're a math circle group trying to solve a square. It is clearly God telling us that we have sinned.
Well, sure. Let's click the impossible button. We'll see.
Lloyd, Joyce, what do you guys think before we click this real quick?
Do you think it's possible, or should we just try harder?
I think it is possible, but I want to see what if it's not possible or not. Click it.
It gives us a
All right,
question-
let's check.
It gives us a question mark. It gets scammed.
You gotta
Check.
check it. Check.
Oh,
It's possible.
We got
Oh, no.
scammed. We gotta figure this out. Are we over time yet? We're 8:03. Well, we kind of started at like 7:02, but whatever.
All right, guys. If you want to leave, that's okay because class is over. But if you want to stay and figure out the puzzle, that's fine too. So.
Yeah. Also, the Jamboard will be on the Discord, so you guys will be able to view it, but you guys won't be able to edit anything, so that like other people can look through the solution. So we'll post that later, along with the discussion problem for this puzzle.
But if you have any questions about it, like you can always ask us on Discord server or just on the question board.
Yeah, feel
Thank you
free to
so
ping us
much.
on Discord as well. Just don't spam ping.
Joyce, what was
Ping.
that?
can we really ping the instructors? This seems like a dream.
Wait, I think Joyce has a question.
No, I didn't say anything.
Oh, okay. That's fine. Well, are you guys gonna stay for the solution or are you guys gonna sign out? Just let us know. So
Whatever. We're gonna keep on working on it. Let's try to figure this out. There's got to be a. Should we just reset? I feel like we messed
yeah,
it
just
up.
reset.
Okay, let's try to think about what do we know for sure is true.
Let's start with the red. The Q has to be up and red.
Are you sure
No,
about it?
up.
I don't think it's gonna be up.
No, it has to be up because if you go down, there's nowhere to go.
I think the red should just stay in the middle. Oh, it needs a
What?
direction. Shoot. No, but think
Oh
about
no.
this.
Wait,
That means this has to be red as well. And then where does this come from?
wait. Reset. I got it. The Q is to the right,
Oh, handle my
Oh.
green brain.
What?
Ayo.
and it's red.
Oh, what is this?
And then the one is down in red. Red.
Oh, he's
red,
figured it out.
good.
He's figured it out.
Handle pioneering the new math squares.
Right. So
Inland
we
Empire
got
math
the red
square.
loop. Now let's do the blue one.
Oh my god, this is actually kind of hard. What is this?
Now we know use Philip's observation that the top right corner has to be blue.
Yes, my very wise decision.
Remember, these can be separate blue loops. They don't have to all be blue. I mean, if I'm feeling like it, I can just go like purple.
No,
I don't think that's quite the solution. Joyce, do you have an idea?
Oh yeah, this is definitely it.
I'm not sure, dude. There's two other blue ones.
I'm still kind of confused.
What specifically like are you confused about? Like are you still not understanding the rules or
I understand the rules. I don't know where we are right now.
oh
I
so
also don't know where we are, so we're just trying
Well-
we're going off any lead we have, but right now we're trying to solve the blue one. So
right, so like in my opinion, I think we're done with the red one. The color red is set. So now we're just trying to figure out the rest of the puzzle. I think we should start with blue since we already have an arrow in it and we have a couple colors, but that's just like my opinion. But if you have a better idea, just let us know. We could try it because no one really has the solution right here. So
ready to try anything?
Is 4 red?
This one?
The arrow.
Which one? This one?
Yeah.
Probably not. Could it work? 1, 2, 3, 4. Yeah, it could
Yeah,
work.
I don't really think so because we already have like a complete loop here. So I think we're done with the color red.
Okay.
Yeah, you might want to go off with blue and see what happens.
Yeah, I'm kind of stuck on the blue. If the
Perhaps
four
it
is
goes
red,
like this, a
there's
loop
nowhere to
like
go.
this, like that.
How do we get to the 4? Is the 4 just not part of the blue loop? It's like yellow or something? I mean, I guess it makes it. I guess.
Oh
it-
wait, I think I got it, guys. Check this out. All right, I think what might be working here is like this. It's like a special loop. It's like 8, right? I think that works, right?
Let's try it, I guess.
No, you have to first make the thing left. No, this one,
What?
this one. It's 1 going to the left,
Oh, yeah.
right?
Oh,
And then you go all the way. That one's blue.
big brain.
Oh.
Oh, I guess I see where you're coming from. Yeah, that makes sense.
Right, it's going to, yeah, right.
Oh, that works.
Oh, and this one is what? This one is blue as well.
Okay,
Because you have to,
knock that one out. Yeah.
right, so now we're done
By
with
that
the blue
logic,
one.
this is red. So Joyce was right about the 4. We
Wait,
can just
really?
take that one red and ignore it because there's no other way to reach that, right? There's no way to reach that one red. The 4 arrow, so we should just make it red.
Wait, then that makes the reds, because we have to be able to reach 4 in a cycle.
No, you
Don't
don't.
we?
No, you don't. It just has to work here. It fits through. If you go from 4, it goes to
Oh,
1
oh
down.
wait, then yeah, Joyce, you are correct. Yeah, it was red. I was
Yeah.
wrong. You're right. Yeah, good job. All right, I think now red and blue are both done. So let's just do the yellow.
All right, now this looks pretty simple, right? I know, maybe not. Okay, I think I have an idea. I think this works. If we just make a death cycle here, and we just make everything go up to there. If we get this one up here, so this one needs to reach up, so that'd be a 2. And I can guess we can make this one a 2. I guess you can make this one 1. And I guess you can just make this one 2.
I think you just solved the whole puzzle.
No!
Wait,
No.
All right, Hambo, you are right. You can't do it like this. Shoot.
I'm pretty sure you have to form a whole loop.
That's actually that's impossible though. How are we gonna reach the 4 red on the side?
Exactly. That's why I think we messed up on the red.
I'm confused.
I'm also confused. I'm so lost. What is happening?
Okay, I'm pretty confused as well. Let me check the rules real quick.
We never really read the rules for this, right? Oh my god. Scam.
Wait, what is this called?
Oh, colored loops. Yeah, colored loops. I was right.
All right, so
You check the rules?
yeah, I'm looking at the rules right now, and
Did it say anything about this? Yeah, I can check the rules too. What am I doing?
okay, I'm not sure. It
Okay.
says that you have to form a loop exactly.
No, they just need to have a number and direction. So maybe I just messed up my numbers. They don't have to form a loop. It never said anything about a loop. This goes to 1, which goes to 1, 2, 1, 2, 1, 1, 2, 1, 2. It works.
Yep, Jonathan. So I was right. You have to like, it has to be a complete loop. So you have to start on any arrow and go to all of the same colored arrows and then go back to the same arrow.
We got scammed.
So we gotta restart.
1, 2, 3. No. We can fix this. Trust me. I can fix this. Wait,
Well-
that's 1? Okay, we can't fix this. Restart.
No, because the red is already incorrect, right?
Oh my god, this is actually so hard.
No, but I think we have the blue. The blue is already good. So let's just do the blue real quick.
I forgot what it was. It was the figure 8.
Yeah. I think something like this.
That is not what you had.
Joyce, do you remember what we had?
I shouldn't have just screenshot it.
I
No.
believe that.
Okay, Jonathan, we know that the top right is blue and 1. Ha. Interesting.
Oh my god.
Well, this isn't very good.
Wait, what?
I can't check the meeting recording right now. We just
All right, I have an idea. Let's just start with the red again, since we got the blue from the red. We'll just start with the red. All right.
This is actually such a hard problem. This doesn't make any sense.
Okay, so perhaps we have to go up this time. So we're going up.
Perhaps there's a green color.
No, let's start with up this time. So 1 is up, and another up.
Boom.
So that's
All
it.
right, so that's already a complete loop.
I have no idea what I'm doing. I had no idea this was gonna be this hard.
Wait, Jonathan, can I have remote control real quick?
Yeah. Don't install virus or something on my computer.
Okay, so
Hembo about to install virus on Jonathan's paper.
I gotta go download some OSU aimbot or something on some like shady website.
all right, so I'm pretty confident that this is what we had in the first place, right? Is that correct?
I don't know. You're not done yet.
Huh. I seriously can't remember what we had. I wish we took a picture.
I mean, if
I think
I
it was
stop,
something like this.
wait, I'm gonna stop the meeting recording and I'll go check it.
No, it's fine, Jonathan. That's cheating.
How is that cheating? We already solved it once.
No, because if you don't remember, that means you didn't really get the concept, right? Oh, perhaps it's nah. This is pretty hard.
He's admitting defeat.
No, I'm not. Okay, this doesn't quite work.
I'm just gonna sit back and watch Hambo try to solve this.
Okay, what did we do last time? We went down,
I have no idea.
right? And then we did this. This is what we had last time, right?
I guess.
And yeah, that's what we had last time. And we went this way.
The red was a complete loop, right?
Yeah, but this wasn't correct. And then when we did the
No,
blue,
because you can't reach the. Oh, you can. Maybe that works. At this point, we're gonna be here all night.
but we're just doing this for the blue ones. So the blue was
Mm.
Oh wait, I got the blue. It's like this.
I can't even think.
Wait,
That doesn't work.
I just lost the blue again.
Oh no, I got it. I got you. Stop. Stop moving. Stop moving.
Right, that's the figure 8 we had. Exactly.
Oh my god, I feel smart.
All right, let me just write the path real quick.
That totally.
And now we can restart again. Reset.
I'm taking a screenshot. 1 second. Hey, no, Hambo, stop.
Oh, it's fine. I have the
No,
annotation on the
no,
screen.
no, I'm gonna take a screenshot. Oh my god, it really scared me. Okay, got it. We have a screenshot.
Okay, why is it not resetting?
Because I was moving my mouse so you can't hit it.
All right. Okay, now we have the blue again. So, okay, do you want to just do it?
Wait,
Just
stop
do-
moving your mouse, stop moving your mouse. Wait, I'm gonna put the screenshot here so I don't forget it. All right, cool.
I can't control your screen. Do you? Oh, yeah, I got it.
You're controlling it right now.
All right, so that's what we had. Right, this is what we had before.
Yeah.
The complete cycle of blues. Yeah, so now we're done with the blues once again. And now let's do the red.
There's gotta be, we gotta think of this 4. We just gotta think of the 4. 1, 2, 3, 4. Oh, I see it. Wait, this is actually impossible. There's no way to reach the 4 arrow.
Which is why that means we have to loop.
Oh, no, I got it. Oh, big brain, big brain, big brain.
Did you just make the loop?
I think so.
Yeah, you just made the loop. That's smart. All right, Joyce, now you can do the yellow. Now we have the correct ones.
No idea how I got that. Wait, we're literally wrong.
What? No.
Look at the bottom left.
Mm-hmm. Oh wait, no, that's because that's supposed to be blue.
Yeah, but how are you gonna reach that from the other? Oh, okay. No, we're okay. We're okay. We're okay.
All right, Joyce, now you can do the yellow.
We're almost there. This is it.
Mm-hmm. This is it.
Then you literally just put the rest of stuff yellow.
Yeah, I have no idea how the arrows are gonna go. Let me think. Shoot.
Wait. What?
Maybe like this? No, but this gets stuck in itself. It can't do that. It has to do like, I don't know. It's gotta go like this. To go here, and if we go here, then this has to go down. Oh, I figured it out. I literally just figured it out. I think I got it. No way. Is that it?
Yep, that's it.
That was too hard. That was way too hard. No, this
Fill in the
puzzle,
numbers. Fill in the numbers. Fill in the numbers first.
bro, that puzzle should have not, that should have been like puzzle 50. They should have added some more. That was way too hard for this. That was insane.
That's why there's only 11 puzzles.
Oh my god.
All right, now
Yes.
check.
No!
What?
All right, we're ending the meeting. Thank you everyone for coming.
Jonathan, that's the 2. That's the 2. This one.
Wait, did I mess
Yes,
up?
finally,
Wait, did I mess up?
sweet success.
Jonathan, this one is a 2.
Jonathan doxed.
Jonathan,
wait.
this one is a 2. We're done. This one is a 2.
I almost mauled it. Okay.
All right, now it's correct.
I was about to end the meeting. But there you go.
All right, we
Cool.
solved it. Congratulations, everyone.
That would have been a
Thank you.
discussion problem, but we solved it. How much minutes we went 20 minutes over time. All right, my bad.
All right, we're very sorry, but thank you for staying after.
Okay, bye-bye.
All
Bye.
right, good
Discussion
job.
problems will be up if you have
Good job,
problems
Joyce.
about-
Good job, Loy.
If you guys have any questions about the problems we went over, feel free to ping us in Discord. Jamboard will be up. All right.
Okay, bye.
Leave a
Yeah,
like and subscribe. Smash that like button.